Folks, hello and welcome to week 8. Here we are at the conclusion of the course. I appreciate all the great work that everybody has invested to get through the material. We've got an interesting duo of problem sets to look at here for week 8, talking about analysis of variance and tests of independence. What's neat about both is each has another distribution to look at. We've had Z distributions, we've had T distributions, and now we'll look at something called the F distribution that we use for analysis of variance, and then we'll look at something called the chi-square distribution that you have read about for tests of independence. And let's see, so the first thing that I will say about analysis of variance in chapter 12 is this will look very similar to what we did to hypothesis testing back a couple weeks ago. But now, instead of comparing the means of two variables or the proportions of two variables, we're going to be comparing means of three or more variables. And as you've gone through the reading, and this is kind of a screenshot from Learning Objective 12.2, because I wanted to point out a couple things. One, the idea, again, recall now that we're switching gears here, going from not Z and T distributions, but to the F distribution, and there's a picture of that distribution in the reading. Let's see, there are some assumptions here that we use to go through these types of problems. The one thing that I wanted to highlight here that I'm sure it came to a lot of your minds is the fact that, well, if I know how to test two variables at a time, couldn't I test two variables 3 times, and that way I could draw some conclusions about the, I should say, three sets of two variables, 1 to 2, 2 to 3, and 1 to 3 to figure out where I may not have means that are equivalent. And the one thing that is key to point out here is that you can, as you continue to do those tests on those variables, what happens is the probability of a type 1 error begins to increase. And so that typically will throw off your results. And so we use this F distribution through analysis of variance to help us test 3 or more means together. And the good news about this, the way that I think it's best for us to tackle these problems this week, there's actually only one that I think you have to do for chapter 12. But I think we can do this through Excel pretty easily. And so what I wanted to do is I wanted to introduce the problem and then kind of go through this 5 or 6 step process that's outlined in the book, and then show you how to get into Excel and do this. And I think we can make this fairly straightforward. So if I go into this problem here, it's problem 51 from the book in chapter 12, and it involves the Lincolnville School District bus data. And what we're going to do is we're going to conduct a test of hypothesis to reveal whether the mean maintenance cost is equal for all 3 bus manufacturers. I'll show you quickly how to do this at the 0.01 level of significance, and then you can do the same thing for 0.05. What I have below that is not related to problem 51, but it's and it's part of Learning Objective 12. Let me see, 12-2. So this is the cutout from 12-2 and explains the process that we're going to go through here. And again, it's a very similar to what we did with 2 variables. The null hypothesis will be is that the means for all, in our case, all of the bus types, the maintenance costs are the same, and then the alternative would be that they are not all equal. The level of significance must be selected in step 2. We're going to do 0.01 as well. Determine the test statistic. That'll be done nicely through Excel. And then formulate a decision rule. That's effectively how do we come up with the F critical value. And again, that is, you can obviously go through this discussion if you like. And once you understand it, and it involves degrees of freedom here, the calculations are quite simple. But once you understand that, I think it's easiest to just go through this in Excel, especially if you're going to have large data sets. And then obviously, once you know the test statistic and the critical value, obviously you can make your decision from that point. So let me switch over to Excel here. What I have done what I have done is I have taken all the manufacturer and maintenance cost data. I just clipped it out of the main body, and then I moved it here to a new sheet. And what I did is once I had all the data, I just sorted it by bus type, and then I just cut the maintenance costs for all the Bluebird buses. There they are. All the Kaiser buses. There they are, and all of the, I believe it's Thompson. Yeah, all the Thompson buses are here. So the data that you want to feed into Excel should look like this, if this is how you want to do it. If you want to do it by hand, by all means, but I think it would be helpful to go through this using Excel. So again, by bus type, Bluebird, Kaiser, and Thompson. And so what I'm doing is I want to compare the means. And right now I'm assuming that the mean maintenance cost for Bluebird, Kaiser, and Thompson, that they are equal. Now, the way that we're going to do this, and what I'll explain what I've done over here in a second, but here, let me show you how we get this data into Excel. So once I have it broken down into columns here, I'll go to Data, and then I'll go to Data Analysis. And the very first option you see at the top is this ANOVA, A-N-O-V-A, for a single factor. And we'll click OK. So remember, this is single factor. And let's see. The first thing you need to do is you need to put in the input range, and notice that obviously the number of entries in each column is not the same, but just put in the entire rectangle so that you get the largest number here, which is the Bluebird. Obviously, you're going to have some blank spaces for Kaiser and Thompson, but Excel knows how to handle that. So I'll put in the input range. I will tell Excel that my data is grouped by columns. I will tell Excel that I have labels in the first row, and that I want to test the relationship between these three means at the 0.01 level of significance. And then you can pick a cell in your sheet to ask for the output range, and then you can hit OK. Now I'm not gonna do this because I don't want to give away the punchline here. But what you're going to get is you're going to get a table that looks like this. It'll say ANOVA, single factor, and then it'll tell you your groups. If you want to spell it out, that's fine. But I use Bluebird, Kaiser, and Thompson, the number of data points for each, and then you'll have data that fills in here. So you'll have the sum of all the data, the average, and then the variance, just basic statistics. Now down here, Excel uses, so there's two main categories of variation that's described in the book. Between groups and within groups is typically the way I categorize it, but the book uses treatment error and just error that you get that is within a certain group. So when you see treatment and error in the book and you try to correspond this with Excel, treatment is between groups, error is within groups. Now, so you'll get, you'll get some sum of squares data here. That is all explained in the book. Degrees of freedom, that is, again, based on the number of groups and then the number of entry points within the total number of categories. So you have three categories. You have probably have about 80 data points here looking at the number of degrees of freedom. The thing that you want to look at is over here. So what I'm saying is when you go ahead and you run this result, what you'll get in the column here that says F, this will be your F statistic, which again is calculated here. Let's see, determine the F statistic, right? Which you can do here. And then over here, you'll get the p-value that's associated with comparing this F statistic to this F critical value. And it's very similar to what we have seen before. You can either look at the p-value or you can compare the F statistic to the F critical value, and then you can make your conclusion. It will be very straightforward once you see these values here on how to make that or how to draw that conclusion. But again, I think it's much easier to go through this using Excel, and then what I'm really interested in here is your interpretation, not so much the calculations. The calculations can be done however you want to. It's again application and interpretation. So that should get you through that first problem in chapter 12. Now let's go over here and let's talk about. Actually, I don't need that anymore. Let me get rid of this. The next problem they're going to look at, we're going to talk about independence. What are we talking about here? We're talking about more bivariate data. And what we're looking for here as you go through these problems, and this is an introduction to problem 57, which is explained in the book. And so we have some data on gender, male and female, and then attitude towards the deficit. And what we want to know is, do gender and the interpretation or the attitude toward deficit, is there some relationship here, or is there some dependence based on how the genders respond to this question? And the null hypothesis at this point will be that there is no relationship between gender and their attitude towards the deficit. And then the alternative would say that, yes, there is some relationship between gender and attitude. I will talk about this chi-squared critical value here, or chi-squared test statistic here in a minute, and the critical value once I look at your data here real quick. So this is what I have done here. So this is some fictitious data. This is not the actual data that's in the book, but what I want to do is quickly demonstrate this, and then you can go ahead and I think, again, this is something that you're going to want to do in Excel. So you have, let's see, 447 females. You have 444. Again, this is fictitious males. They want, let's say, 225 want to reduce, 150 want to increase the deficit, 70 have no opinion, so on and so forth. So this is the data that you would see. And what you have to do here in order to compute your chi-square value is you have to go through and first of all, you have to find the expected numbers of females that want to reduce the deficit and so on and so forth based on the row totals, 447 for the first row, 444 for the second, and the column totals. And this is all explained very nicely in the book. So the expected value here, so just remember, in terms of the matrix, this entry is the first row, first column. This is the first row, second column, first row, third column. So when we go to get these expected values, it's based on the position of the entry into the matrix. So the expected value here is, again, and this is explained in the book, it's the product of the first column, which is in G4, times the first column, which is in D8, and then you divide by the total number of observations. So row 1 times column 1 divided by 891 says, based on the data here, we should expect about 264 females would want to reduce the deficit, right? So you're going to go through and do that for each one of these first row, first column, first row, second column, first row, third column, and then down here, second row, first column, second row, second column, second row, third column. And then you would just use your row columns and a row and column totals to get the product in the numerator. And then in each case, you would divide it by the total number of observations. I think if you set up a matrix like this and just redo the numbers, you'll figure out this pretty quickly. Then what we're going to do is we're going to take the difference between the actual and the estimated, we're going to square it, and then we're going to divide that value by the expected value. So for each one of these first row, first column, so these 6 entries, we're going to compute the difference between the actual and the expected, square that value, and then divide it by the value in the expected column. If you compute all 6 of those numbers and you add that up, this will be your chi-square value. Chi-square value. And then you can compare that to the critical value that comes from the chi-square table. I think I have that for you here very quickly. I do. What you find here is that, and you can figure this out fairly quickly, that here you have 2 degrees of freedom. And if you were doing this at the I think you're doing this one at the 0.05 level of significance, you will find that the critical value for 2 degrees of freedom is 5.99. If I go back to my spreadsheet here, notice I computed a chi-square value of over 40. So since the chi-square value is greater than the critical value, what you would do in that case according to the